Assalamu alaikum. We will discuss in this video the Cauchy integral theorem and Cauchy integral formula. First, we will start with the Cauchy integral theorem. Cauchy integral theorem says that if f of z is an analytic function in a simply connected domain D, then for any closed path C in D, the integration of this function along this curve C is always equal to 0. Mean to say that if the function is analytic on a simply connected domain D, then if we take any path, closed path in D, the integration of the function along this curve C will always be equal to 0. For example, if we take the function f of z is equal to e to the power z and we integrate this function on a unit circle, since e to the power z is analytic in the entire complex plane, so the integral of this function along C is where C is a unit circle. Unit circle means that the center is origin, and if we draw a circle along this path, it will be 1 unit on right axis, 1 unit on negative side of x, 1 unit on positive side of y, and 1 unit of negative side of z, and the center of the circle will be origin. This is unit circle, you know that. So the integration of this exponential of z, because e to the power z is analytic, so the integration of this function along the curve C will be equal to 0 by Cauchy integral theorem. Similarly, cos z is an analytic function in the entire complex plane, so uh, the integration of cos z is equal to 0 according to this theorem if we integrate this cos z along any closed path C. Similarly, 1 over z square plus 1, the singularity of this function, or mean to say that the function is undefined or the function is not analytic at a point z is equal to 2 iota and z is equal to minus 2 iota. So we are going to integrate this function along C, and C is a unit circle. Now the singularity of this function is z is equal to plus minus 2, and how we can calculate this? Just take the denominator equal to 0 and find out the value of z. So z is equal to plus 2 iota and z is equal to minus 2 iota. But we are going to integrate, so the function is not analytic on the entire complex plane, but these two singularities 2 iota and minus 2 iota lies outside C. Because C is unit circle, so 2 iota will be here and minus 2 iota will be on negative side of y, and the unit circle goes to 1 unit on positive y-axis and 1 unit on negative y-axis. Thus the function 1 over z square plus 4 is analytic on this region, this curve C, and by Cauchy integral theorem the integration of this function along C, where C is unit circle, is always equal to 0. Cauchy integral formula is the main topic, and this is very important. Cauchy integral formula says that let f of z be analytic in a simply connected domain D, then for any point z0 in D and any simple closed path C in D that encloses z0, then the integration of the function f of z over z minus z0 dz is equal to 2 pi iota into f of z0. This formula says that if z0 is a singular point of the integrand of the whole function and z0 lies inside C, then the integration, the integrand can be described by this f of z over z minus the singularity, and the integration of this function will be always 2 pi iota into f of z0. F of z0 means the function f of z, which is here in the denominator of the function, all the terms without z minus z naught is actually your f of z. Just plug the singularity z naught in the function. So 2 pi iota f of z naught is the integration of such type of function. So what is the main difference between Cauchy integral theorem and Cauchy integral formula is that Cauchy integral theorem is just for an analytic function, mean to say that if there is no singular point inside the circles, inside the curve C, but if the singularity lies inside C, then we will use Cauchy integral formula, and we will calculate the integration of such type of function by 2 pi over type of z naught. For example, let there is a function e to the power z divided by z minus 2. This is the integrand e to the power z divided by z minus 2, and we are going to calculate this integration along a curve C, where C is any closed contour closing enclosing z naught is equal to 2. Mean to say that z naught is equal to 2 lies inside C. C any contour enclosing z naught, matlab z naught lies inside C. Now this function, the singularity of this function is 2. Just if we put z is equal to 2 here, we get this function undefined. So z is equal to 2 is singularity, and singularity lies inside C. Now here we cannot use the Cauchy integral theorem, we will use Cauchy integral formula. So let this whole integrand e to the power z divided by z minus 2 is equal to g of z. We will differentiate what is our f of z. Here in the formula we have f of z over z minus z naught. So if we take the whole integrand by e to the power z divided by z minus 2, and z is equal to 2, yani our singularity is z naught is equal to 2, so it means that our f of z is just e to the power z. Uh, if we equate this g of z with this integrand z minus z naught, z minus z naught, and without z minus z naught, the whole term is f of z. So f of z is just e to the power z. So the integration of this function is very simple according to this formula, and this will be 2 pi iota into f of z naught. And what is z naught? Z naught is 2, right? So 2 pi iota into f of z, which is e to the power z, and just put z is equal to 2 here, we get 2 pi iota into e to the power 2. This is the integration of this function along a curve C, which encloses the singularity z naught is equal to 2. We will discuss some more example in the next video, and it will be clear to you after when we solve 2-3 example using this Cauchy integral formula. Thank you.